Hello, Math Studies students, and welcome to your online lesson. Today we'll be solving quadratic equations once again, but this time we will be using the quadratic formula rather than factoring techniques, which we had seen in previous lessons. We will know we are successful when we can efficiently solve quadratic equations. A reminder of what a quadratic equation is. Quadratic equation is usually, or often, or can be expressed in the following form. The most important aspect of this is it must have an x squared. To be an equation, it must have an equal sign, and in order to use our quadratic formula, we must have it set equal to 0. So if it's not set equal to 0, we have to rearrange it using some algebra. The a is always the coefficient of x squared, again, the number that's multiplying the x squared, and if there's no number in front of the x squared, we again assume that's 1. B is our coefficient of x, again, it's the number that's multiplying the x, and then c is our constant, it's the number with no x's at all. Any of these numbers could be missing as well, like there could be no c term, and so then we would assume that c is 0. The quadratic formula, on the other hand, though it is an equation because it has an equal sign, a formula is different than just a regular quadratic equation, which is again letting us know that all of this stuff is equal to something, which is in this case 0 when we set up our quadratic equations. Quadratic formula, a formula of any kind in fact, is an equation that we are able to plug things into to find a value or answer. So we're going to be plugging things in. There's no, there's a few numbers in here, but mostly I've got a bunch of variables that I'm plugging in. The first variable I want to talk about is x, and that's the one variable that we won't be plugging in. It's also the part of this equation that people forget about. And it's really important because the whole point of using this formula is to find out what x actually is. X is equal to all of this other stuff. And this is what we're going to plug in our formula to actually find the value or values of x. And so we're plugging in our b value, which again is the same number that we had here in front of x. But we are not plugging in x, just the number in front of x. That same b value gets plugged in here and squared. We have an a value, which can get plugged here and at the bottom. And then finally, our c value, or our constant, gets plugged in there. But again, there will be no x's plugged in anywhere on the right side of this formula. No x's anywhere. The only x that we will have is just our answer. And this is really just going to be hanging out here until you're all done with the formula on the right side of this equation or formula here. All right, so why do we care about the quadratic formula? We already know how to factor quadratics. And by factoring them, we can get them ready to be solved and use algebraic techniques from that point on. But there are some quadratics that are not factorable. And for that reason, the quadratic formula is very helpful. And we're going to look at one of those examples right now. So I look at this quadratic equation that we have here. It's already set equal to 0. I like that. There's nothing written in front of x squared. So I assume that there is a value of 1 implied there. So I'm going to begin by writing down my c term, which is 3, just like I would for a normal factoring problem when there's no a value expressed. And I'm going to list the possible factors. 3 is prime, so the only thing that goes into it is 1 and itself. 2 does not go into it. It's not an even number. And as I look here at my b term, I can see that it's negative, and yet my c term, that 3, is positive. So that means not one, but both of these numbers would need to be negative in order to multiply to be a positive 3, but yet add to be this negative value here. However, when I add them together, I do get a negative value, but it's not negative 5. And there's no other whole number factors of 3. So this is not factorable. So we need another method. Enter the quadratic formula. So I'm going to start by writing down that quadratic formula. And I recommend this anytime we use a formula, is first to write down what the actual formula is. So we have x is equal to the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. And there's songs and other mnemonic or memorization devices for getting this down, but again, it's a very common formula, and it's always starting with that opposite of b, plus or minus, and this is what might allow us to have two possible answers as we continue on. The square root of this part, which is called the discriminant, b squared minus 4ac, which we might talk about on a different lesson, all divided by 2a. So now I'm going to start plugging some values in. So I have a b value here of -5. And it might be helpful just to write these down. So my b is -5. What about my a value? Well, the a is always the coefficient of x. There's nothing written in front of x, so I would assume it is 1. And then my c value is 3, positive. So I'm plugging these in. Again, I have -5. Well, right away, it's the opposite of -5, or -5 becomes a +5. And if you want to write it down that way right from the beginning, I support that. And then we have our b value getting squared now. Again, it's a -5. We want to square both the 5 and the negative. It's going to be a -5 times itself. So those parentheses are really important, both for writing it here as well as in the calculator. Minus our 4 times our a value, which we know is just 1, and then finally times our c value, which is 3. All of this is going to be over 2 times our a value, which is once again 1. All right. So a -5, as we said, becomes just 5. Then I have plus or minus, and we're going to see if we can simplify some of this inside the radical, or the square root here. -5 times -5 becomes 25. And then I have -4 times 1, which is just 4, times 3, which gives me 12. So minus 12 going on here. And all of that is over 2 times 1. So I can keep simplifying. I have 5 plus or minus the square root of 25 minus 12, which is 13, all over 2. Now, as I look at this, a couple things to talk about, plus or minus. So what we want to do is we want to do 2 different expressions now. So we're essentially going to split this off into 2 parts, and I'm going to jump them up here. One where I do 5 plus the square root of 13 over 2, and one where I do 5 minus the square root of 13 over 2. Now, square root of 13. I can square root 9 and get 3. I can square root 16 and get 4, but 13 does not have a whole number square root. It is not a perfect square. So I'm going to use my technology from this point moving on, but let me first write down my expressions here. So I have 5 plus the square root of 13 over 2. And then I also have 5 minus the square root of 13 over 2. All right, now using my calculator, I'm going to find out what each of these values are. And I can plug them all directly into my machine in one step. So I have a group. I have a numerator here. And I need to tell the calculator that if I want to do it in one step. You could also break this up into multiple steps, but I would rather just do it in one single step. So I'm going to take parentheses to say this is my numerator, where all that stuff is grouped together at the top, 5 plus, and now I'm going to do second, and the square root is the x squared button. So you'll notice that on the calculator, it automatically opened up a square root and a parentheses. On some of the more updated operating systems, it might look a little bit different than that, but one way or another, the calculator is going to start grouping it for you as soon as you open that square root. And again, that was second, and then the squared button. And now I'm going to type in my 13. That's the only thing in my square root at the moment, so I'm going to close that parentheses, and that closes my square root. So you can see that I have a parenthesis here and a parenthesis here that's been closed, but I still have this one for the numerator. So I need to close that parenthesis as well to say that's the end of my numerator. That's the end of the stuff on top, and now I'm going to divide by 2. And I can hit enter, and I get this value here of 4.30277568. In math studies, whenever we have a problem that doesn't tell us how to round and we don't know the exact value, we can we should, in fact, always round to 3 significant figures. So again, in the quadratic formula, remember, it was x equals. That's what we were dealing with here. X equals, and then we split our equation into the plus and the minus versions. And so I'm going to round this to 3 significant figures. I have the 4, the 3, and the 0 would be the third, but I still need to round. Since the number after it is 2, I'm going to round down, and so I end up with approximately 4.30. 3 significant figures, and again, that's what we want to do anytime directions don't tell us how much to round to. Now I need to do this problem one more time, but I want to do it with the minus sign. Well, I do not need to retype everything on the calculator. Press second, and then enter, and it will do your last entry, the last thing that you typed in. Now I'm just going to cursor back until I get to my plus sign, and right on top of it, not using a negative, but using a minus sign, I'm going to replace that. I'm going to hit enter once again, still rounding to 3 significant figures. So we've got the 6, the 9, and the 7. Following the 7 is a 2, so again, we would round down, which means keep it the same. and I'm going to have 0.697, or you could put 0.697. And those are the solutions to this quadratic equation. Again, it looked so friendly in the beginning, like we might have nice values, but as it turns out, it wasn't factorable, and the quadratic formula allowed us to actually get the values for this. For our second example, we have x squared minus 2x equals 1.25. So here's another reason why we might want to use the quadratic formula when you don't have whole numbers. So it's not to say that you couldn't possibly factor it, but it's not factorable using the techniques that we've looked at where we use whole number factors. So the other thing to notice here is we do not have our quadratic equation set equal to 0. So I need to do a little algebra. I'm going to subtract 1.25 from both sides. I end up with x squared minus 2x minus 1.25. And then over here, those are just going to cancel out, leaving us with 0. Now this equation is ready to use in our quadratic formula. I'm going to write the quadratic formula down. X is equal to the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. Start plugging in values. Again, it helps to write them down. Sometimes our a is once again 1. Our b this time, again, the number in front of the x is negative 2. And finally, our c term is negative 1.25. And I'm looking at my modified equation that we have here rather than the one that they started with, because again, the c was not on the correct side of the equation. It was not equal to 0 yet, so we have to use the negative 1.25. So we can start plugging things in now. We have x is equal to the opposite of b. Well, b was negative 2. What's the opposite of negative 2? Positive 2. So this time I jumped right to that. You could write minus 2, but it's just going to make more work for us in the end. Now we have our b squared, which is going to be negative 2 squared. And if you already know that negative 2 times negative 2 is 4, feel free to write that down. We have 4 times our a term, which is 1, our c term, which is negative 1.25. And then we're going to put all of that over our 2 times our a, which is just 1. All right, I'm going to bring this equation up over here. And now that I've written it up there, I'm going to erase the original so that I can bring up my calculator. So this time, I'm going to attempt to put the whole thing in one step. Since there's so many decimals here, I don't want to even start to simplify without putting it in the calculator. Thing to remember, we have a large numerator here, and then we also have some other groups going on. So I'm going to start off with a parenthesis, and this is to say I have a group of stuff in the numerator, starting with my positive 2. I'm going to focus on the plus first, and then we'll do the minus second. So we have plus, now the square root of, and this parenthesis is for my whole square root. Now, right after the square root here, the thing that I have written is a parenthesis for my negative 2 squared. So I'm still going to write that parenthesis, negative 2, close my parentheses. I'm going to square it, either using the square button or the caret, minus 4 times 1, and I'm using parentheses for that, but I could also use the times symbol, times negative 1.25. Again, I used parentheses, but I could have used the times symbol. Now I am closing my parenthesis for the square root, and I have one more parenthesis to close for. That is my entire numerator. Now I'm going to divide by my denominator. Let's open another group for my denominator, and it's 2, and this time I'll use a times symbol, times 1, which many of us already knew was just going to be 2, and that could save you a little bit of extra work there as well. All right, now I'm going to hit enter, and I've got a value of 2.5. So one of my values is 2.5. I'm going to run this all one more time. So I'm pressing second and then enter. But this time, instead of using a plus sign in the beginning, I'm going to use the minus sign because we had plus or minus as our possible values here for this quadratic. I've replaced the plus with a minus sign. I hit enter once again, and my second possible x value is exactly negative 0.5 or negative 1/2. And voila, I've used the quadratic equation or the quadratic formula to solve this quadratic equation with decimals. We have one last example here that we've looked at in other classes. I'm not going to solve this one all the way due to time, but I just want to point out that we do not have it equal to 0 yet, so we could start off by subtracting 8x from both sides. 8x's would cancel out, leaving nothing or 0. 4x squared and negative 8x are not like terms. One is x squared, one is x, so they can't be combined. And now I have a quadratic equation that I could use in the quadratic formula. The thing I want to point out before we end this lesson is what is our a, our b, and our c term. Well, our a is obviously the number in front of the x squared, or the coefficient of x squared, which is in this case 4. The b, we want to keep our sign with it, so it's a negative 8. That is the coefficient of x. And our c term, or our constant, we don't have one. So what would we use? 0. And then we could plug these 3 values into our quadratic formula to solve it. All right, so that was solving quadratic equations using the quadratic formula. Till next time.